Good afternoon, everybody. So I am Brad Genereaux, Global Lead for Healthcare Alliances at Nvidia. I have been involved in healthcare for my entire career. I spent 10 years working in hospitals in Canada and 10 years working at a medical imaging company, AGFA, before I joined Nvidia back in 2019. I've also been involved in interoperability for the majority of my career. So I am former co-chair of DICOM, the medical imaging standard. I'm currently the chair of IHE Radiology Planning Committee to drive profiles. And that's what I'm going to be talking about today in terms of how we can drive interoperability for AI at worldwide scales and why it's so important and the tools that we need to be able to drive this. From the audience, how many people are more on the IT or IS side? Okay, perfect. So a little bit. What's so important as I've always been on the IS and IT, but worked very closely with clinicians to really make this successful. Because it's really that partnership between clinical champions, IT champions, IS champions, informatics champions to really drive this, even before we had AI. But in the rise of these deep learning and now LLM solutions, we need to be able to bridge this and integrate it inside of our application. So just because I come from the radiology space, this will be kind of a little more radiology centric. But when I think about the workflow of, a referring physician writes an order, we protocol that order, we acquire the images, we do any sort of post-processing on the images, we may run AI models against it, our radiologist will write a report, and we distribute that report. But when we think about what actually happens between on the systems layer and the people layer, there's so much variability across a hospital system or enterprise, across a state, across the country, across the world, in terms of who's performing the different tasks, what systems they're actually using, who manufactures those systems, what vendors are in the mix, so because we might have a RIS, a PACS, a VNA, an AI algorithm, multiple AI algorithms, a reporting system, an EMR system, an HL7 engine, a DICOM router, who are all made by different companies. We have to think about what happens when we deviate from the traditional workflow. As soon as we go through this process and we say, oh, actually, this AI algorithm doesn't handle images from a vendor X system, but it does handle it from vendor Y, what actually happens? And we have to think about how this data is represented across each step of this workflow and how we're sharing that between. And this is where standards have come in, like DICOM, since 1991, and HL7 has been around since 1985. Actually, the current version that we use for medical imaging, version 3, has been around for more than close to 30 years now. It's the same version, which is pretty impressive compared to everything else on the planet. So, as Dimitri was talking about, Bridge is so important. It'll be coming out in a couple of months at tops. Really, to provide the blueprint for resilient integration and deployment across the ecosystem. Really kind of thinking about all the different milestones of governance, which is so important. Part of that, though, is connecting with other frameworks that exist in the ecosystem, right? We have Chai, as Dimitri talked about, that helps give us a framework of trust. We have frameworks like MONAI, the Medical Open Network for AI, frameworks that allow us to build deep learning solutions, computer vision solutions that can help us recognize, indications for stroke and for cancer and for pneumonia, pneumothorax, and everything else across the board. And then we have frameworks like IHE that help us connect these different systems together. And that's what I'm going to be talking about for the next 5 or 10 minutes. So in the standard space, we have HL7, We have DICOM, and we have many other supporting frameworks. So HL7 is the metadata. This is the the orders. This is the reports. This is the demographics. This is the allergy information. This is all the stuff that we communicate in terms of metadata, trigger messages from one system to another. DICOM is our framework for pixel payloads primarily. We can include structured reports. We can include things like modality work lists. We can include things like videos. Even pathology can be encoded in DICOM. And then we also have frameworks like SNOMED for different ontologies, LOINC, RADLEX. Chuck's here. I love gametes. I come back to gametes all the time, especially when I talk about the number of AI solutions that we actually need. Gametes is a great way for us to identify how many things that we can actually see in medical images. There's things like CDS hooks and other things, but all these things come together to help tell a story. We need standards because if you think about all the different vendors for all the different actors across that entire ecosystem, we all have to work together in a neutral way so that we don't have to spend time as vendors reinventing the wheel and figuring out for every single deployment, how do we actually connect these different systems together? So this reduces production costs for everybody. It reduces the amount of development time to create these solutions, installation times. We have confidence that when we take these solutions into the field, that they're actually going to work. It reduces risks for deployments. It enables the developers to focus on the things that add value, and it enables clinicians, physicians, radiologists to focus on the things that matter to them to drive patient care and not have to worry about how do I get information from system A to system B. But even if we have these standards, if we say, hey, these things both talk DICOM, therefore it's going to work, that's actually not true. Because if I have a modality like an X-ray that talks DICOM, and I have a PACS that can talk DICOM, they're actually two different components in the same workflow, but they're actually doing very different things. And the same thing applies to AI as well. Just because I have an AI solution that can talk DICOM doesn't mean it's actually meaningful. We actually need to put it inside of a workflow. On top of standards to drive interoperability, we need to be thinking about things that enable the solutions from an end-to-end perspective. Standards themselves are foundational. They're not entire solutions. They can be very broad. They could also be very narrow at the same time, which is really interesting. Because once we think about DICOM, it's focused on imaging and doesn't really care about what happens about lab work or other things. There's lots of standards. Even in the world of medical imaging, we have, as soon as you go to pathology, there's 11 different standards. DICOM just came in and said, hey, we're the 12th. We also find that they're very focused. So IHE has come along to help drive connecting these standards into clinical workflows that matter. They started back in 1999, where they came together in a basement of a hotel, many different vendors to test how these systems can integrate together in standardized workflows. It started out with something called SWF, or scheduled workflow, and now there's, in the radiology domain itself, something like about 75 different profiles that we can drive. It's driven through the community. These profiles are all freely available, and every year, actually twice a year, once in Europe and once in North America, vendors come together to test their applications and make sure that they work together. And so it's just one of the things in our bag of tools, in addition to HL7 and DICOM and the other ontologies and standards, and pull that together within profiling. And this adapts into the world of AI. When we think about the AI workflows that we now have, Typically, it's something like this, where we acquire our images, we process and post-process, we drive AI to do inference, we then have our radiologists read the images in addition to the objects that AI may have created, and then based on that we write a report. Maybe if the AI got it wrong, we can drive fine-tuning and relearning. We also have an entire training workflows where we're going to take a corpus of ground truth, train or fine-tune models, package them up into solutions, and then deliver them and connect them into various platforms like ADOC, for example. IHE is defined already, as I mentioned, scheduled workflow. In the AI space, there's profiles like AIWI and AIR, and I'll talk a little bit about that in just a second. There's also a foundational paper that was put out back in 2021 called AI Interoperability in Imaging. It's an end-to-end positioning paper of how we can leverage all of the different standards in service to driving artificial intelligence and computer vision in the medical imaging space. We look at those same stops in the journey we write the order, we do the protocol, we acquire the images. As we look at all these stops in the journey and say, well, how can AI help us? AI can help us in suggesting the next exam to order. It can help us in ensuring that we got the patient positioned on the table before we acquire the images. As we acquire the images, if there are issues with the images, let's say the movement artifacts or other issues, we can catch that using AI before the patient has got dressed and gone home, and we have to recall them the next day because we don't have good enough images to write a report on. We could use AI to help clean up the images. We could use AI to help us do our pre-processing before the radiologist looks at the images. Can we help with measurements? Can we help with doing grading and scoring, characterizing? Once we have that, we could use AI to help us write reports, write snippets, summarize content. We could use AI to help us in the treatment planning and provide insights into that. We could zoom out of that entire process and look at things like population health across an entire region or an enterprise or a country. We could use AI to help us to derive departmental efficiencies as well inside the radiology department. So there's lots of stops in that journey, and in that white paper it talks about all the different types of workflows. Similarly, in the third chapter, we actually walk through every stop in that journey from creating our repositories of ground truth to creating specific data sets, to training models, to packaging up those models, to doing validation for various services like, from a regulatory perspective, from a payer perspective, from an end user or clinician perspective, to doing the inference, to collecting the feedback, and then thinking about all the things that this entire process needs from a security perspective, from a data bias perspective, from a security perspective, from a provenance perspective, all the things that we need to be thinking about. And each of the stops in that journey, what are the different components? We have a profile, for example, called AI Workflow and Imaging, AIWI, that talks about how do we actually drive efficient processing from when we have an imaging study to get an insight and that delivered back into our packs for the radiologist to read. The old style, which was basically flip over the fence and then wait for a response to come back, is not something that is truly enterprise scalable at global levels. And this is why standards like DICOM and with IHE help to drive that. Evaluating where we have, in this case, an AI orchestrator that can help us organize all the studies that are coming in, prioritize, get them farmed out to the different AI algorithms that could process it, and get feedback back into the entire workflow for the radiologist to read. And from I'll say an AI ops or an ML ops or an informatics perspective, being able to assess how that process is actually happening. So that is what AIWI is. I know I'm running out of time. The other thing that IHE has helped to define is something called AIR, or AI results. If you think about in medical imaging, if I have an imaging study and I want to highlight an area of concern, let's say there's the patient is being tested for possible stroke. We have images of the brain. We want to highlight an area of the brain that's of concern. How do we do that? Well, we could use GSPS, so grayscale presentation state, to draw arrows, or perhaps draw a rectangle around the area of concern. We could use something called parametric maps to highlight in colors areas of green and areas of red. We could use structured reporting to describe the areas of concern. We could use what's called secondary capture and create additional images we push back into the packs that we can then just draw on top of the areas with our own annotations. There are so many different ways that we can represent that. That is very problematic as a radiologist, especially as they move between different healthcare systems or switching to different applications throughout the course of their careers. So AIR is something that was created to help standardize the way that we represent the different findings and insights that AI finds that we can then share back out. So these are the kinds of things that the community has been putting together from a vendor perspective in concert with users, radiologists, clinicians, all their feedback to build something that is useful for everybody. So, just in conclusion then, as we think about how do we find solutions and connect them at worldwide scale, interoperability is so important as we integrate these things together. We need to have interoperable data structures, how we describe the data. We need interoperable transport, how we communicate the data between different systems. And only then will we be able to have interoperable human plus AI workflows, that we bring these things together in order to really drive transformational change within healthcare systems. Thank you very much.